Hey everybody, Mr. Judson here. Don't forget, if you're watching this video early enough, we have a Teams meeting for everyone who's involved with Central Washington. That'll be at 11 o'clock today. All right, so what we want to look at for today is solving integrals using partial fractions. And so, what does that mean? That means if I have an integral that looks like this, 8 over x squared plus 4x minus 12 dx. Just glancing at this, maybe that could be an arctangent. We could probably make that work. But if we have to use partial fractions, which again, Central Washington would tell us, solve this integral using partial fractions. And what it means is, what two fractions did you add together to get this expression? Okay, what two fractions? And so to do this, I would need to first of all just take this expression. We'll forget the integral here for a minute. I would say 8 over x squared plus 4x minus 12 is equal to one fraction plus another fraction. So in order to figure out what the two fractions are, I want to go ahead and factor this denominator. So this would be x times x. Two numbers you multiply to get 12 and subtract to get 4. Sounds like a positive 6 and a negative 2. So one of these fractions would be something over x plus 6, and the other one is going to be something over x minus 2. The question is, what goes in that numerator? And we don't really know, so what we're going to do is we're going to call this numerator A and this numerator B, and what we need to do is we need to figure out some numbers to plug into that. All right? So let me just go ahead and erase this. So in order to solve for A and B, what we first of all want to do is get rid of the fractions. And the way you do that, if you think back to an Algebra 3-4 class or even pre-calculus, if we're solving an equation, my opinion is we never want fractions in there. And the way you get rid of it is multiply everything by the least common denominator, which is going to be this right here, because I just factored that to get these two. Both of these are factors of this denominator. So I'm going to multiply every fraction on both sides by x plus 6 times x minus 2. Do the same thing here, x plus 6 times x minus 2, and the same thing here, x plus 6 times x minus 2. So I know that if I multiply these two right here, I'm going to get this expression, so all of that cancels. And I know the x plus 6's will cancel here, and the x minus 2's will cancel here. So now what I have is an expression that looks like this. Or an equation that looks like this. 8 equals a times x minus 2 plus b times x plus 6. And so then what we do to solve this is we just go ahead and say, let's just let x equal some number. So if x equals, and I can pick any number I want. What I really want to do is pick two numbers. And if I just randomly pick two numbers, what I'll get is two equations with two variables, and I could solve that as a system. But if you really want to make it easy on yourself, pick numbers that'll make these factors equal 0. So if I let x equal 2, then what I get is 8 equals 2 minus 2 is 0. 0 times a is just 0. Over here, if x equals 2, I get 8 times b. And so now I can go ahead and solve that and say b equals 1. So I just figured out what this fraction right here is. It's going to be 1 over x minus 2. And so now what I want to do is I want to say if x equals, I'm thinking what would make this equal 0? Negative 6. So if I plug that in, I still have 8 over here. Negative 6 minus 2, that'd be a negative 8 times a. And if I put a negative 6 in here, I get 0. So divide by a negative 8, that means that a equals a negative 1. So I've just figured out what the two fractions are that I would have added to get this right here. So now what I have is I've got the integral of negative 1 over x plus 6 plus 1 over x minus 2. dx. And I've always kind of liked, these problems because they're not nearly as difficult as trig substitution or integration by parts. Once you know what these two fractions are, really solving this integral is pretty easy. What I'm going to do is I'm going to divide it up into two separate integrals. I'll move this negative to the outside. Actually, I'll just switch them around. I'll put the positive one first. So I got the integral of 1 over x minus 2 dx minus the integral of 1 over x plus 6 dx. And so then if you look at that, this is a u prime over u. So my answer is just natural log absolute value of x minus 2 minus, this is also a u prime over u. It's going to happen a lot with these problems. And so I get natural log absolute value of x plus 6 plus c. And since I'm subtracting with exponents, I could use the properties of logs and just write this as natural log absolute value of x minus 2 over x plus 6 plus c. Remember, when you subtract exponents, that happens when you're dividing. There it is. There's my answer. All right, so I'd like to say that's it, and they're all as simple as this, but there are a couple rules we have to follow. Not every fraction ends up with denominators that look like these two. Okay, it's possible you could have some different denominators. So let's take a look at some rules. All right, so here's some rules. Rule number 1, if I have something over and I factor my denominator and I get something like this, then my two fractions are going to be a over x plus b over x plus a. That's kind of like the one we just did. If this denominator happened to be x plus or minus some number, that factor would go right here. Okay? And the general idea is that your numerator should always be 1 degree less than the denominator. So if this is x to the 1 power, we should just have some constant or some number up here in the numerator. Okay? All right, rule number 2. If I have something over x plus a squared, so this would mean I factored my denominator and I got the same factor twice. Well then, you need to have a over x plus a, and then you would think it would be b over x plus a, but then you have a common denominator already. We don't want those denominators to be the same. So this needs to go up by 1 degree. So this would be x plus a squared. So if this would have been to the 3rd power, I would have this fraction plus c over x plus a to the 3rd. Okay, my numerator is still 1 degree less than this factor, but not the overall denominator, because this will be an x squared by the time you get finished with it. All right, and then our third rule, and this is all we have, is just 3 rules to look at. If I have something over x plus a times x squared plus b, and this could even be something like x squared plus bx plus c, some kind of quadratic expression. Then when you divide this up into 2 fractions, so we'd have a over x plus a, but for the second fraction, if my denominator has an x squared in it, remember the numerator needs to be 1 degree less. So if this is a quadratic expression, then what I want up here is a linear expression. So this would be bx plus c, and so what I have is 2 things I have to figure out for that fraction. And so that might involve a little more work. Okay? And we'll take a look at examples and see how to deal with that. All right, so there's our rules. If you don't have them written down, write them down somewhere so you have those available to look at. And let's try another problem. All right, so this is kind of similar to the first one, although my numerator is a little bit different. And so I still need to go ahead and factor this and then break this down into 2 separate fractions. So you guys go ahead and give that a shot. All right, so I would write this as x plus 4 over, if I factor this denominator, I'm going to get x times x. 2 numbers you multiply to get 3 and add to get 4. It's got to be plus 3 and plus 1. So this would equal a over x plus 3 plus b over x plus 1. All right? This is just a linear factor, so 1 degree less would be just a constant. And then I'm going to multiply through by the least common denominator. So, if you need to write this down, go ahead and write it down. But I think it's possible to just kind of picture this being up here and written here and written here. And so I know that this whole denominator would cancel with whatever I write down as my least common denominator. So I would end up with x plus 4. If I had an x plus 3 times x plus 1 here, it's the x plus 3's that would cancel. So I've got a times x plus 1. And over here, if I had an x plus 3 and an x plus 1, it's the x plus 1's that would cancel. So I'd have b times x plus 3. The most common mistake that people make here is they try to take shortcuts and they just write down a times x plus 3 plus b times x plus 1. And right away we've made a mistake and we're heading down the wrong path. All right, so I want to let x equal a number that would make this go to 0. So we'll say -1. Now here's the part that's different. In the first problem we had just a number, but now we've got to plug -1 into here and work with that. So -1 plus 4, that would be 3. Put a -1 here, you get 0. Put a -1 here, you get 2b. And so that means to us, if I divide by 2, I get b equals 3/2. And then if I let x equal -3, so plug in a -3 here, you get 1. Plug in a -3 here, you get -2a, and a -3 here, you get 0. So if I divide by a -2, that means that a equals a -1/2. All right, so the 2 fractions that I would have added together to get this would have been a -1/2 over x plus 3 plus 3/2 over x plus 1. And then dx. And again, real important, just make sure you get the right fraction with the right denominator. again, if we get lazy and a little bit sloppy, we can get those switched around, and again, that'll mess up our answer. So now I want to divide this up into two different fractions. I'll also bring these numerators out in front of each. So I've got a negative 1/2 times the integral of 1 over x plus 3 dx plus 3/2 times the integral of 1 over x plus 1 dx. And so if I look at that, I've got a negative 1/2 natural log absolute value of x plus 3 plus 3/2 natural log absolute value of x plus 1 plus c. And we're done. So if I decide to combine these, the hard part here is I have to bring those exponents up first. So, I think this answer is okay, but if somebody took it a little bit farther, I'll write this one first since it's positive. You'd have natural log absolute value of x plus 1 raised to the 3/2 minus natural log absolute value of x plus 3 raised to the 1/2, which I could have just called a square root. And then if I combine this into just one natural log, I would have x plus 1 to the 3/2. I'll just keep the absolute value in there. X plus 1 to the 3/2 over the square root of x plus 3 plus c. So either one of those is a good answer. I didn't check the book. I'm not sure if our book would have this as an answer or if they'd have this right here. All right, let's try another one. All right, here we go. Yeah, let's step it up a notch here, huh? All right, so first thing we got to do is factor it and figure out what fractions did we add together to get this. You guys go ahead and try it. All right, so let's see, in the denominator, if I factor out an x first, then what I'm left with is x squared plus 2x plus 1. And so if I factor that, I'd have x times x plus 1 plus 1. So let's see, x squared plus x plus another x, that's 2x plus 1, and then multiply everything times x. You don't really have to factor the numerator. I would say the only reason you might want to do that is what if something cancels? Then we'd have an equivalent expression that might make this a little bit easier. So let me just try that real quick. Let's see, if I go 5x and x, and if I go 3 and 2, that'd be 15x, and 2x does not add up to 20. If I go 6 and 1, that'd be 30 and 1. Nope. Put 6 here, you got 6 and 5, that's 11. What if I took that 3 and 2 and I went 3 here, 2 there, that'd be 10. Nope, that does not factor. Okay, so we're not worried about the numerator. 5x squared plus 20x plus 6. And because we got the same factor twice, I should probably write this as x plus 1 squared. So now we're going to have to use our second rule for this. So my first fraction is going to be a over x. My next one will be b over x plus 1. And my third fraction will be c over x plus 1 squared. So if I multiply everything through by the least common denominator, so let me just write it up here just so we have something to look at. X times x plus 1 squared. So if I multiply that times this fraction, everything cancels. And so I'll end up with just 5x squared plus 20x plus 6. If I multiply here, the only thing that'll cancel is the x's. So I'll have a times x plus 1 squared. Here, if I multiply, the x plus 1's will cancel, but I'll still have an x and another x plus 1. So b times x plus 1. And then for this last one, if I multiply this times this term, the x plus 1 squares will cancel, and I'll just be left with cx. Alright, so now we play our what if game. If x equals, probably the easiest number to choose is 0. So that means I'm going to plug in a 0 here, and I'll be left with 6. When I plug in a 0 here, I get 1 squared, which is 1. So that's just a. Here I'll get 0. Here I'll get 0. So there we go. A equals 6. If we let x equal a negative 1, then what we get is a negative 1 squared, which is 1, times 5, that's 5, minus 20, so 5 minus 20, that's a negative 15, plus 6, we get a negative 9. And that will equal, if I put a negative 1 here, I get 0, so that term's gone. If I put a negative 1 here, I get 0, so that term's gone. If I put a negative 1 here, I get negative c, so c must equal 9. And now I got to figure out what b is. Well, I've already chosen all the numbers that will cause things to zero out. So remember what I said in the beginning, you can choose any number you want. So what's the next easiest number besides 0 and negative 1? Yeah, I heard that. X equals 1. Alright, so if I plug that in, I get 5 plus 20, that's 25, plus 6, that's 31. That's going to equal, I'm plugging in a 1, so this would be 2 squared, that's 4a. If I plug in a 1 here, I get 2 times 1, that's 2 times b. And then if I plug a 1 in here, I get c. Okay, but we already know that a equals 6. So if I put a 6 in here and multiply, I'd get 24. I know that c equals 9, so I'll put that right here. And so now I just got to solve for b. So if I add these two together, I would get a positive 33. Move it over and subtract, you get a negative 2 equals 2b. And so that means b equals a negative 1. And so now I got my three fractions. And I'm just going to go ahead and divide this up into three separate integrals here. So my first integral, a is 6, so I've got the integral of 6 over x dx. So for my second fraction, I've got b equals negative 1. So that means minus the integral of 1 over x plus 1 dx. And for my third integral, I've got c equals 9. So plus the integral of 9 over x plus 1 squared dx. And so now I just need to solve each of those. So here if I move the 6 to the outside, I would have 1 over x. That's a u prime over u. So I'm going to get 6 natural log absolute value of x. This is a u prime over u. So minus natural log absolute value of x plus 1. And what is that? I don't know if you guys see it, but first thing I see is something inside parentheses raised to an exponent. That should make me think what? Substitution, right? So let me move the 9 to the outside. I'm going to write this as the integral of x plus 1 to the negative 2 and then dx. And so let's see, if I do my substitution, I'll just write some stuff right here. I'm going to let u equal x plus 1. So du is going to equal 1, and I just took the derivative of x. Derivative of 1 is 0. So I've got what I need to put in a du. I'll substitute and call this u to the negative 2. So this integral becomes 9 times the integral of u to the negative 2 du, which when I solve that, I'm going to get 9, add 1 to the exponent, you get u to the negative 1, divided by the new exponent, plus c. And so that's just going to be a negative 9 over u, or negative 9 over x plus 1, plus c. If I bring these two things down, I'm going to have a, let's see, a natural log of absolute value, x to the 6th power. We're subtracting, so that means divide, over x plus 1. And there it is. There's my answer. Nothing you can do to combine these two. Just is what it is, and that's it. So the one thing that's different about this one is if we run out of numbers to plug in, pick whatever you want, and just don't forget, we already know what A is equal to and what C is equal to, so you can plug those in afterwards, and then solve for B. So that's what we have for today. We'll get into some more difficult ones here on not Tuesday, because remember, this is Memorial Day weekend. I won't be making videos on Monday, so Tuesday I'll start making videos, and so I won't have anything for you guys for Tuesday, so I guess you get an extra day in there. So Wednesday we'll pick up with this and get some more difficult ones in there. Alright, that's it, you guys. I'll talk to you later on today, and other than that, have a good weekend, stay safe, and enjoy your Memorial Day.